Okay, now that we have seen ATI's Render Monkey and we've gotten ourselves comfortable with what the user interface looks like, it's time to create a shader.
That's right.
And we're going to start super simple. We're just going to make a very basic OpenGL shader that's just going to have color.
Yep.
Then we'll start worrying about things like a lighting model.
Right.
See if we can pull off something that's kind of a Lambert-like effect.
Right.
Okay? But before we do that, there's a couple of things that we need to talk about. Now, GLSL is a language that looks very much like C.
Yep,
The syntax
very
is super, super close. But there are some things that you're going to need to familiarize yourself with that's a bit different.
Right, and the first thing is, I guess, just the data types that we have.
Absolutely.
I mean, obviously, a lot of people are familiar. If you look on the side here, we've seen void.
Yes.
We've seen float, int, bool, double. But when you start working with graphics, they needed to throw in a few different extra data types specific to creating shaders.
That's right.
Things like vec2, which means we have two vectors that has an x and a y. Vec3, x, y, and z. Vec4, x, y, z, and w. Mat, which is a matrix, 2x2, 3x3, 4x4. Int, we have integer vectors, integer vector 3, Boolean vectors, etc., etc. So just a whole lot of extra data types that we need to work with.
That's right. So just let you guys know up front, you're going to need to become comfortable looking at, well, Vec2, Vec3, and Vec4 are very popular.
Right,
They're
they
used heavily. But you're going to need to become familiar with the GLSL data types.
That's right.
Another thing you're going to need to become familiar with is the type qualifiers. Uniform, varying, and attribute. These play a very important role.
And we've kind of seen this at the beginning when we were changing the diffuse amount, the ambient color, etc. Those were uniform. Those were something that is the same, or global variables, if you will, that you see in C. Something that when we change once, you can see everywhere inside of your vertex or your fragment shaders, and you can use those and change them. But
That's right.
Just remember, you cannot change these inside of your shaders. They're for artists to adjust.
Exactly.
Varying. These are things that allow us to pass data from the vertex shader over to the fragment shader.
The fragment shader. Remember how the pipeline works. We can't go from the fragment shader back to the vertex shader.
Right.
It's got to go vertex, then fragment.
It's one direction.
Exactly.
And finally, we have attribute, which is something that allows us to pass attributes or data from OpenGL over into our shaders, our vertex shader.
That's right.
So things like the normal, which is on a per vertex level, the color of a particular vertex, this is all information that is an attribute.
Or any other type of information we'd like to add.
Exactly.
I mean, we can come up with
anything.
Crazy off-the-wall stuff.
Exactly.
As long as it has some sort of meaning to us that we're going to end up using in the fragment shader, we can put it there.
Exactly. And these are very, very useful, so keep these in mind because we will use them. Finally, our lighting models. And we'll come back to this as we go back.
Yeah, let's just do that. We'll come back to these in just a minute. We do have a lighting model for Fong and for Lambert.
Right, we've seen the Fong lighting model way back in the lighting
And we
lesson.
talked about it, kind of traced through it a little bit with some lights. But now the cool thing is, over the next few videos, we're going to make both of these.
Yes, we
are.
are.
We're going to show you how we apply that math. But for starters, let's jump over into RenderMan. Render Monkey.
Yep.
Just kidding, Pixar. And let's start with as simple of an OpenGL shader as we can make.
Right, so we have an empty effect workspace here. Let's go ahead and add a default effect. Go to OpenGL. Simply add an OpenGL default effect.
That's right.
And this just throws in some very simple, a blue sphere or whatever color that is.
Purplish blue, I guess.
Purplish blue.
And you'll notice we have one pass, which is pass 0. The model, by default, we just get a sphere that we've got it on. You can't tell it's really a sphere because there's no lighting information.
Yeah.
And now we have a vertex program and a fragment program. Both of these are populated with just a small amount of code.
Right, so let me just open this up real quick. So you'll see that we start out with a void main void. And you saw this in the last lesson, but just kind of want to drive this home. It's exactly like in C.
Yeah, I was about to say, Joel, they're C++ programmers.
I know.
They've seen main everywhere.
Everywhere. And this is where obviously your function is going to start for your vertex program and the same exact thing for your fragment program.
Right.
So a lot like C, just keep that in mind. Now, one thing that, if you remember back in the pipeline overview, one thing that the original legacy version would do is transform it for you. And that's what this here is doing, F transform. This is doing all the transformations and essentially putting it back into the legacy version, this one line. So you kind of have what you had before.
Right. And Fragment program, if we take a look at that, that's very easy, where we're just simply setting a color right now.
Right.
And that color has a little bit of red and a whole lot more blue, giving us that slightly purple effect.
So what I could do is come into here, and let me change this over to a complete red, just to show you how this works. And notice I use a vec4, and I'm initializing this to a 4 vector.
That's right. Another thing to point out is that as Joel is making these changes right now, we're not seeing anything update back in our preview window. That is a different okay. That's a different thing. We can start adjusting variables as we add them to our effect in real time because basically RenderMonkey knows what you're doing. Hey, he's adjusting the slider. But when you're in the middle of typing in code, it doesn't know that it needs to recompile and show you what the effect looks like.
Right, and we wouldn't want it to.
And we wouldn't want it to. That's right. So now that you've made these changes, you just need to simply recompile it.
Right. So simply press F8. And dink, it appears in our preview window.
Look at that.
Or what if we wanted to...
Let's do exactly what I was just talking about. What if we want a variable? Right. What if we want an artist to be able to change the color with some sort of color slider?
Right.
How do we do it?
Well, let's go ahead and right-click on the default OpenGL effect here. Actually, let me rename this to our custom shader.
Oh, yeah, that's cool.
Nice. Come in here, right-click, add variable. And what we're looking for here is a color.
Right.
So we can simply add a color here. And let me call this shader color.
Okay.
When I double-click on this, I get a little viewport here, a little window.
Which is very nice.
Very nice. We can come and modify the color. And what we want to do is let this color be portrayed in here.
Okay.
So how do we do this? Well, let's go into our Fragment program here, because that's where the color is being set.
Right.
And all we need to do is say uniform vec3, and then we call it my color, or something like that. And then I can come into here and simply set this over to my color. Yeah?
Okay. I'm just wondering how you're getting my color from shader color.
Excuse me. Shader color. Wow, I'm just totally out of base here.
Basically, this is the connection between the variable you just added and how we're now accessing it in our program. Joel was just testing me.
I was testing him to make sure he was paying attention. And remember, if we bring this up here, notice we have 4 components: red, green, and blue, and alpha.
That's right.
So this is 4 separate floating point values. And we can switch this over to floating point so you can see exactly what we're getting past here.
Cool.
So when I create it, remember I create a uniform, which means it's a global variable. It's a vec4, so it has RGB and A. Shader color, this name needs to be the same as what you have here. And we simply set the frag color equal to shader color. Okay. And we're done. So if we come over into here and start modifying, check it out.
Now we can do this in real time.
Yep.
That's very nice.
Very, very cool.
And, of course, now also our artist editor, if you click on that, the little palette at the top, I was going to do this one up here.
Oh, okay, yeah.
Yeah, now you'll see that that's starting to come to life as well.
Yep, so we can modify it directly from inside of here as well.
Just in case you want to, for whatever reason, keep this window open, as you're adding more and more variables, it could be kind of handy having everything right there.
Definitely.
Accessible.
So you could pin it down if you wanted to and just bring it up.
Oh, aren't you cool? Now you really are making it feel like Visual Studio. Okay, I don't like that. Anyways.
So anyway, at this point, why don't we go ahead and create our Lambert?
Okay.
Or wait. Actually, let's first add our texture into it.
Want to do a texture?
Yeah, we can have a texture that's going to be applied to this. Now, when we have our model here, you can see we can change the model to whatever. Currently, it's a sphere, and it does have texture coordinates on it. Okay. That's something that's important to keep in mind. So let's create a texture first. So let's right-click, add a texture, add a 2D texture, and let's say we have a cloud. Okay? So we can right-click on this guy, and you can see that we have our little cloud here. And it does have an alpha and a regular RGB. Now, to get access to this, what we need to do is right-click on our pass and create a texture object. And inside of here, this is going to reference whatever texture that we want. So we can come in here, right-click on the texture, and reference our cloud. And now, using this name right here, texture 0, or whatever one we use, we can access that inside of our code. So let me call this, I don't know, my texture.
Cloud texture.
Okay, cloud texture. Cloud texture.
Okay.
And then inside of my fragment code right here, what I need to do, well, actually first in my vertex code, I need a few things. One thing I need is my texture coordinates, and I also need to say, okay, I need to pass the texture coordinates that are from my vertices. Remember, inside of our OpenGL function, or our code inside of C++, what we used to do is call set our texture coordinates. And we need to pass that information from the vertex program over into the fragment program. So what we can do is simply do a varying So this is varying across every single vertex. And this is going to be vec2, because we have two, a U and a V, called text chord.
Right.
And we need to pass this over, so all we need to do is get the texture coordinates to the Fragment program. So text chord, I can type, really.
Equals GL underscore multi-text chord
0.xy.
Right.
Now what this
to gain access. Okay, go ahead.
What this is doing here, GL underscore multi-text chord 0. What this is a multi-texture coordinate. Basically, on our video card, we have multiple texture units that we can have access to. And we're accessing the texture coordinates for unit 0, the first one that we have access to. And we're getting the UV coordinate for this particular vertex as it's looping through this for every single vertex of our object.
Right.
And we're putting this into our varying text chord variable, if you will. So now we have access to it in the Fragment program.
Almost. Yeah, exactly. Now we need to come over here and do the same thing. We're going to need to do varying to text chord again. And at that point, now we have access later on in the rendering pipeline when we get into the shader or the vertex shader or pixel shader itself, the Fragment program. Now we have access to it. Now we can use it.
Right. But before we actually use this, we need the texture to work with. We don't really have access to our cloud texture just yet. So what we need to do is get a sampler. So what we're going to do is type a uniform sampler 2D called cloud texture. And a sampler 2D is what allows us to get information from a 2D texture. If you had a 3D texture, for example, it would be a sampler 3D. You would pass to the name, same as the name that you get in your pass here, and then you have access to that inside of your code. Now, let's say I wanted to change this over. So I don't want the color anymore. Instead, I want to just get the information off the texture.
Right.
So what I need to do is call texture2D, which is a function call, and it's looking for three things, actually. Well, we'll only be using two of these. The sampler, so what sampler are we getting from, or what texture are we getting it from?
That would be cloud texture.
Cloud texture. What coordinate? Well, we got passed it from the vertex program to the Fragment program as text chord.
So text chord.
So a text chord.
So now we're using both those.
Compile this and check it out. We now have the texture applied to this guy. Very cool.
I hate to say this, but it is as simple as that.
Yep, very simple.
Of course, you're still going to have to do your texture handling back over in your C++ application and all.
Right. We have to pass these attributes accordingly.
That's right.
So what if we wanted to take shader color and continue making changes to it? Well, I can still do that. We have our texture coordinate 2D, which is returning a color to us. We can multiply this by our shader color to have our color influenced by the artist modify our shader. So we can come in here and just say shader color. Save this and check it out. As I change the shader color, it's now tinting the texture color to our shader color.
That's right.
Very cool.
Now this is all very simple so far because at the moment we're not taking lighting into account at all.
Right.
So if we wanted to start bringing lighting into the mix, this is where things get a bit more interesting. And this is where also you need to have a bit of an understanding about some of the math involved with determining lighting.
That's right. So one of the things we need to do is, well, one thing. First off, we need a light position. We need to specify where our light's going to be. So let's come into our custom shader here. Right-click, add a vector in here, a float 3, which is specifying our position. Dink. And we'll simply call this our light position. So let me just call it FV light position, kind of to follow the convention of ATI here. And let's go ahead and make this an artist variable, because this is something that we want the artist to be able to change.
Right.
So that's one thing we need. Now, inside of our vertex program, we need to pass a little bit of information over into our Fragment program. One thing it needs to know the normal so that we can calculate that. In fact, let me go over to my PowerPoint real quick here, just to kind of drive this home. Inside of here, as you probably remember, KA, this is the ambience, and this is the intensity here, and we're looping through every single light. In this case, we only have one light, so we need to execute this block of code once.
Right.
So what we need is n, which is the normal at the vertex that we're dealing with. So we need that information. The other thing we need is the light vector. And this is a unit vector that points from the current point to the light. And this needs to be a normalized vector. You dot these two together and multiply that by the diffuse color. And that's going to give you your final lighting color. And that'll allow us to utilize lights.
And this is exactly what we're about to do.
Exactly. So let me come back over into here. All right, so the vertex program. Let me first get the normal out of the way. So let me create a varying normal. So a vec3 normal. Or again, varying is what allows us to pass information from vertex over into fragment. So let's populate normal with the right information. Very simple. Normal equals GL normal matrix multiplied by GL normal. Again, these two here are something that is provided to us inside of GLSL that the Vertex program can access. Normal matrix is the matrix that deforms the current normal. Mm-hmm. And GL normal is the normal, the undeformed normal.
So you want to take just a second. Mm-hmm. You see all these GL underscores we have in there. So kind of, we've got a whole table of these things available to us.
Yes, we do.
We don't have a table presented to show you guys. I'm just wanting everybody to be aware that there is a series of things available that's coming down the pipeline to us that we can pull from.
Exactly.
I just want people to be aware of that.
Right. And again, we do have a GL position that we're modifying for the Vertex. The texture coordinate that we got a second ago, normal matrix, a conversion, a model view matrix, etc. This is all accessible to us. And as we meet each one, I'll point it out. So we got our normal, and that's now accessible in our Fragment program. The next thing I need to do is create that L vector. So I'm going to create another varying here, and I'm going to call this light direction. Light direction.
Okay.
And let me go ahead and come down over into here and set light direction equal to, and I need to take the current position of the light. This is in a current space right now. And remember, in our model view matrix inside of OpenGL, that's how we can view our scene. Mm-hmm. So what we need to do is transform this light into the proper coordinate space. So we need to multiply it by the model view matrix. So we simply do a GL model view matrix. And this needs to be multiplied by our light position. But our light position is a vec3. A model view matrix, when you multiply that by something, it needs to be a vec4. So we can convert this into a vec4 by simply having vec4, passing it a vec3, and one extra value. So FV light position, and just 1. And now we have the properly deformed light position. Now this is just the position of the light. Now we need to subtract that with the object position. So we need to get the current vertex position, if you will. So let me come into here, and let me say vec4 object position. And this is going to equal GL model view matrix multiplied by GL vertex. And GL vertex holds the current position of the vertex, but again, we're going to need to deform it according to the model view matrix.
That's right.
So once we have the object position, we can minus the light direction, or the light position, by the object position, and that's going to give us the correct vector. Is this all making sense?
Yep, absolutely.
So we can come in here, put this in parentheses here, and in this case, light direction is going to be a vec3, so we'll just take the x, y, and z components of it, and subtract this with object position. And this one is also dot x, y, and z.
Perfect.
And with that should be everything. We now have our light direction. Let's see, what else are we going to need? I think that's everything we're going to need. Now we can come over into our Fragment program, and all we need to do is dot the light direction, the normal with the light direction. So if I come back over into here, the first thing is I need to get access to those. So we'll type our varying vec3 light direction and our varying vec3 normal. And in fact, before I forget, let me come back into here and make sure that, I didn't type in the FV light position. So let me just bring this in here. So uniform vec3 FV light position. And this is just giving the Vertex program access to our global variable.
Exactly.
So back in here, what I'm going to do is simply calculate the facing ratio, if you will, so that we can find out exactly the floating value that we need to calculate our final intensity. So I'll just declare a local variable called facing ratio. And this is going to equal dot. And of course, all it's going to do is the normal with our light direction. Remember, if I go back into the PowerPoint real quick here, you notice we have the hats on top of both of these vectors. Mm-hmm. And just to kind of drive this home, these two vectors need to be normalized.
Right.
And back in our vertex shader, we didn't actually normalize these. So we can simply normalize them by calling the normalize function. And then normalize the light direction as well. And can't kind of see things here, so let me just move this over. And that should be it. Now we have our facing ratio, and we just multiply the color that we have here by that, and it should shade our object. So let me take this and do multiply by facing ratio. And compile this. And
something's working somewhat because
and made it completely dark. But let me go ahead and see what I'm doing wrong here. Let's see, our GL model view matrix, but okay. The light position is currently at 0, 0, 0. So nothing is wrong here.
It's
the light is just
inside the...
Inside, exactly. So I can set a minimum and maximum for my light position. I wanted to have a fairly high minimum and maximum. So I'll set this to 100 and set this to 100. And this influences how this can be modified. So I can move this way out, move this up a little bit. And if you look here, we already have a little bit of light going on here. So I can move this a little bit forward. Move this a little bit. There we go. Now we can actually see a little bit of shading going on here. And again, I can even take this a little bit farther. And back in our presentation, you saw that we had an ambient color and a diffuse color. I can go ahead and add those two into here as well. I'm calling it shader color. I'm just going to come in here, change this over to diffuse. Of course, we're going to get a little error here.
That's right.
Not a problem. Come over to our color, and we'll add an ambient color. And then let me go ahead and change this over to diffuse and ambient. And over here, I'm going to change this over into diffuse. So if I recompile this, I'm now getting the proper results. If I come over to here, I can still modify what's going on with this. So we get that.
Cool.
Now I can add in the ambient, and that's really easy. All I need to do is multiply, add onto this our ambient color. But one thing that's the problem here is I'm adding 1 to this entire thing. What I really want to do is add on the ambience of the texture, multiply the ambient with the texture that we're getting. So let me go ahead and create a local variable here, just called the diffuse color. Let me just take this cloud texture here. And let me multiply this by the diffuse color. And then add the ambient.
Multiplied by the diffuse color.
Exactly. Look at this.
Nice.
So now if I start taking this ambience down a little bit,
it up a little,
then that's like we're not having any ambience at all.
Right.
And as you pull this up, as it gets to white...
Now it's as if there's no lighting at all. It's like it's completely self-illuminated or something. Or being hit from light in all directions equally bright.
Yep. So, I mean, I can even turn the diffuse color to black, and I'm still getting the picture here, but with no lighting information whatsoever.
Right.
So with that, we have a completely working ambient shader model. I mean, Lambert model.
That's right.
So I can come down. Let me just turn this down a little bit. Now, if I wanted to, for example, add another light position, let me just talk about what you would have to do to get this working. If I come into my vertex program, I would also need to do another. The normal would be the same, but I'd have to have another light direction.
Come on, we can undo it. Let's just do it real quick.
Okay. So let's go ahead and add in another light position.
Okay.
So let me add a float here. And then we'll call this FE light position 2. So, and let me also make this an artist variable. And of course, it's not going to do anything just yet. Let me go ahead and get that information. So we have a light position 2. We need to send the light direction of our second light. So let me copy and paste this varying vector. So light direction 2.
Right.
And now I need to calculate it. So let me just copy and paste this in, getting light position 2. Right?
Mm-hmm.
So, and this needs to be stored in light direction 2. Now, if I come over into my Fragment program, all I need to do is get that information, so light direction 2. And then instead of just having one of these here, I need 2 facing ratios. One of N dotted with the first light and N dotted with the second light.
That's right.
So I'm going to take this.
Because in the end, it was just a summation of
those
lights together.
Right. So we have a facing ratio 2 and with light direction 2.
Mm-hmm.
And then let me go ahead and take this, and instead of just having one diffuse color multiplied by diffuse multiplied by facing ratio, I'm going to add that entire thing again. So diffuse color multiplied by diffuse multiplied by facing ratio 2. In fact, what we could do, just to make this a little bit more clean, we could have our vec for light 1 color equals...
Yeah, I like this here.
And then multiplied by like that. We can copy and paste this.
And this guy's number
like 2. And with facing ratio 2. And then it's easy. We simply take the first light. Let me just clean this up a little bit. So we have our ambient, so light 1 color, plus light 2 color, plus our ambience. And that's exactly what we had over in our formula, how we had the summation from I to the number of lights.
That's right.
So if I compile this,
Okay, now, again, keep in mind, where is light 2 at? 0, 0, 0.
Right, so let me go ahead and change this to negative 100 and positive 100 and move this light back a little bit. So
right there, you can already see illumination on
both sides.
Yep.
This is let me make this negative 200, just to give us a little bit more flexibility here. Check it out. I have two lights that are directly modifying where it is. In fact, right like that, you can see illumination from here, and illumination from there,
and a little bit of dark between the two.
Right.
Yeah, very nice.
And even at this point, I mean, you can see where we can go from here. Each light could have a separate color. Mm-hmm. Each light could have different a distance maybe, so that falls off after a certain distance with a simple float. I mean, there are just a million different things you can do at this point. I mean, you can just add on and on and on to this shader.
Right. Okay, anything else you can think of that you want to throw in here?
I don't think so. I think that's everything they need to know to kind of get started.
All right, again, the idea of this was just to go through creating a very basic shader. And we've done that with lighting, too.
Yes.
Okay, so with that, that is going to wrap up this video. In the next video, we're going to talk about shader implementation in your application.
Right.
So how do we take this into our application that we're writing over in .NET?
That's right.
And so that's going to wrap up this video. Thanks a lot.